Today we're going to do a little video showing you how to solve the questions on the equation graphing practice booklet that got handed out to you. It's a 19-page booklet that's aimed at just getting you ready for grade 10 pre-calculus math so that you can look at any equation and very quickly in your head, or any linear equation, and very quickly in your head and on paper get a sketch of a graph for it. It's meant to be drill and practice. It's not particularly interpretive. It's just working on skills. The booklet looks like this. That's the first page there. So this part of the video, we'll do it in two parts. This part of the video is for the first 14 pages. And in the first 14 pages, all that you see are equations that look like this. Remember that in an equation, if you write it in this form, the linear equation in this form, the m stands for, of course, the slope of the line, and the b stands for the y-intercept of the line. If these are new ideas to you, or if these are new definitions to you, then you need to look at previous videos. For those of you who just need a quick reminder, slope is a ratio. So I look at this 2, and to me it's the number 2 over 1. And the 2 represents the rise from one point to another, or how much it goes up in the y direction. And the 1 represents the run. And we think of slope as rise divided by run. So looking at this equation, the 3 tells me that I hit the y-axis at 3. And then 2 over 1 tells me that I go up 2 every time I go right 1. So up 2, right 1, and there's another point. And 2 points is all I ever really need to graph a straight line, since I know it's a straight line. And try to make that a little straighter. And there we go. First one done. Next one's more of the same, only the fact that this is a -3 tells me that when I start at -5, at my y-intercept, I'm going to go down 3 and right 1. Since this is a positive 1, it's right is the positive direction when I'm going back and forth, whereas down is the negative direction when I'm going up and down. Having said that, bit of a problem. If I try to count down 3 from this point, I'm going to have a very difficult time staying on the graph. That point's a little too big now. There we go. So I'm going to run out of space in my grid. So -3 over +1, remember, is the same as saying 3 positives over -1. So instead of going down 3 and right 1, I can go up 3 and left 1. So that would mean 1, 2, 3 up and left 1. And I still get a negatively sloped line. In other words, as I go from left to right, I'm going downhill. And once again, that's a little bit off. Lovely. And there we go. Oops. Just taking the time to put arrows on those, since that line does go forever. Sometimes they're very nice to you, and the slope's already in fraction form. So this would be a -2 for a y-intercept, and then up 2 and right 3. So up 2 and right 3. And if I wanted more points, I could just follow the same rule, up 2 and right 3. And once again, beautiful. Okay. Here's one that's a fraction, but again, a negative slope. And at this point, I'm starting to kind of just picture what it is in my head before I even start graphing it. So I've got a mental picture. I know it goes through here. And I know, again, that this negative can count to the top or the bottom of the fraction. So I'll put it on the bottom so that I have more room to work. So I'll go up 7 and left 2. And there's my next point. So again, that's up and that's left. And there's my quick sketch of that. That takes us to this one. I'm glad I put this one in here. Y equals x. What does that mean? Well, remember that there is a number here. It's 1. The numerical coefficient on that x is 1, and I can think of that as 1 over 1. And the number that's here, that I would think of as my y-intercept, is in fact 0. So I go through 0, 0, and then I go up 1 over 1, up 1 over 1, up 1 over 9. And this one, as you can see, is a perfectly diagonal line at 45 degrees. And in some ways, I think of this one as kind of the default setting for a linear equation. So that if I wanted to do something like graph 2x, well, how would it change that black line that was y equals 1x? Well, no problem. These points now just go up twice as steep, but they still go through 0, 0. If I had 3x, it would go up 3 times as steep as y equals x. And if I had y equals, let's do it in red. If I had y equals negative x, it would be the same as the black line, only in the other direction. And if I had something like y equals 1/2 x, well, then it's half as steep as my original black line, and it goes through 1 up 2 over. So that's kind of the way I think about graphing lines. I think of them as they all kind of start like this line, and as soon as you put a number here, it affects how steep it is. If I put a number here, well, then it's just like I took that line. Here, I'll shift it up 4, and I shift it to there. Its y-intercept goes from being 0 to 4, but I didn't change its steepness of 1 unit. So there we go. Let's try one like that again. Y equals x would be exactly 45 degrees. So y equals 3x goes a slope of 3 up, 1 over. 3 up, 1 over, 3 up, 1 over. And it looks something like that. What do I do with that? There's no y in it. So think about it. Let's make a table of values for this. What happens to x when y is 0? Well, x equals 3. What happens when y is 1? X still equals 3. What happens when y is 2? X equals 3. What happens if y was a billion? Well, there's no y in this equation to affect what x is. So if I graph all of these points, notice there's only one place on this graph where x is always 3, and it's along this vertical line. So what does a y equals equation look like that doesn't have an x in it? Well, by the same logic, y will always be negative 4 no matter what points I put in for x. So y will always be negative 4 along there. So that should get you going for the first 14 pages of that booklet. Check out the next video to figure out how to do the next 5 pages of the booklet.